Welcome to today's session on transforming energy, well planning, and drilling optimization. I'm excited to be here with you to really talk through how Databricks is revolutionizing the well planning process. My name is Brett Albo. I'm a solution architect here at Databricks. Sergey Kalitsky will also be joining me today, where I'll be exploring how traditional well planning challenges can be transformed through our comprehensive data intelligence platform. Let me walk through our agenda for the next hour. We'll start off by examining the challenges of traditional well planning, understanding some of the pain points that plague this space, and then we'll dive into a data-driven solution with Databricks showcasing our platform's capabilities and solving some of these challenges. Finally, we'll see these solutions in action as Sergey walks through a comprehensive demo on well planning and drilling optimization. We'll wrap up with a Q&A session, but feel free to add questions to the chat. We have Jackson, who's another solution architect on our team. They're ready to help out and answer questions as they pop up. Before we get started, I'd love to better introduce ourselves. As I mentioned, my name is Brett Albo. I bring 7 years of oil and gas industry experience to Databricks. I have expertise in data science and data engineering. I worked at several upstream companies, including EOG as well as Apache, where I got firsthand knowledge to some of these issues that we'll be discussing today. My most recent stop was at Meta, where I was a data scientist and a data engineer, and I joined Databricks in December of 2024. I'm based in Bernie, Texas. I'll turn it over to Sergey to introduce himself as well.
Yeah, hi everybody. Good morning, good afternoon. Thank you everyone who joined us today. And a few words about me, Sergey Kaletsky, solution architect in Databricks. I have like extensive software engineering background, or 15 years in different engineering companies, technical consultant, right? My industry that I worked on mostly for last 5 years, that was oil and gas, energy. Also media, entertainment. I certified Azure, GCP, and Databricks architect, and also I did some contribution to the OSDU data platform. Thank you, everyone. Over to you, Brett.
Awesome. Cool. Thanks. So let's dive into the topic for today. The energy industry faces lots of significant challenges in well planning that have massive downstream impacts. This is a business critical issue that affects everything from safety to profitability that we'll be diving into today. The subtitle here really says it all. We need to understand the critical link between accurate estimations and operational success. To start off, this conversation will really be sort of centered around the rig schedule. And so I want to introduce that rig schedule. The rig schedule is truly the lifeblood of oil and gas operations. Think of it as the master orchestration document that determines when and where every rig is assigned across all wells in an operation. This document is critical for several reasons. First, accurate scheduling, reduces non-productive time. When rigs sit idle, companies lose money at rates of thousands of dollars per day. Second, it really optimizes everything else within the operation. They impact, the rig schedule impacts project timelines, crew assignments, equipment allocation, and supply chain logistics. When schedules are wrong, the domino effect is immediate and really expansive. I want to walk through one of those sort of domino effects I mentioned when things go wrong. It all starts really in this case with inaccurate time estimations. A drilling engineer working with limited or fragmented data provides a flawed duration projection. This isn't due to incompetence. It's often because they're working with incomplete information or using outdated estimation methods, which we'll discuss more today. This bad projection leads to flawed resource allocation, where rig scheduler creates an unrealistic timeline based on that bad estimate. Now we have equipment conflicts because crews and resources were scheduled based on incorrect assumptions. This in itself causes NPT, which escalates exponentially. This NPT and idle rigs can cascade into budget overruns that can blow past constraints, leading to missed financial targets and threatened milestones. The result of all this really is investor confidence suffers, impacting stock price and ultimately market cap. This isn't theoretical. This is happening across the industry, and what we'll dive into more today. and while obviously the rig schedule has implications at the drilling site itself, it doesn't stop there. Poor rig scheduling creates organizational-wide impact and touches every department. Safety becomes compromised with increased risk exposure and incident potential. Financial bills with budget overruns, cash flow issues, and AFE accuracy problems. Operations face idle crew times costing 50,000 plus dollars per day, equipment conflicts and resource waste. Supply chain struggles with material delivery misalignment and inventory imbalances. Stakeholders, like we already talked about, experience investor confidence erosion and partner relationship strain. And even environmental and regulatory compliance suffer with extended emissions periods and permit timeline violations. This really isn't just a drilling problem, it's an enterprise-wide problem that requires an enterprise solution. Part of what makes the rig schedule so complex is really the sheer number of variables that feed into the decision-making process. We're not just talking about the duration and cost estimations, which we'll be discussing today and are highlighted in red. Those are critical, but we also need, production estimates, well information, lease agreements, resource constraints. There's external inputs such as oil price outlooks, scheduled maintenance windows with vendors, that add a different level of complexity. Each of these inputs can change, and when they do, it can really ripple through the entire schedule. This challenge isn't just about having data, it's about having it integrated, current, and accessible for decision making. So, as we continue to dive into this use case, I want to really introduce two key players in this process that we'll be focusing on today. First is the drilling engineer. Their responsibilities include well trajectory design, drilling parameter optimization, time and cost estimation, risk assessment, and formation evaluation. In regards to this particular sort of use case, one drilling engineer told us that time is money. They're constantly looking on ways to improve the duration or days on location for the different wells they're drilling. Then we have the rig scheduler, whose responsibilities include resource allocation, fleet optimization, project timeline management, crew coordination, and equipment scheduling. Their perspective on this scenario is that my schedules are only as good as the estimates I receive. This highlights the critical dependency between these two roles. The rig scheduler can be incredibly skilled, but if they're working with inaccurate estimates from the drilling engineer, the entire operation can suffer. So, as we get more context on this scenario, let's look at how this process traditionally works out there today and why it leads to these inevitable outcomes we discussed. In the traditional method, we have multiple disparate data sources, vendor cost data, drilling operations reporting coming from source operational systems, geological data that's all living in these separate source databases and systems. The result is that drilling engineers spend days or weeks reconciling numbers between systems, often in curated data systems like Excel. Without a single source of truth, drilling engineers are forced to provide budget and time estimations based on best guesses or templated methodology. They're doing their best with really the fragmented information that they have available. Meanwhile, the rig scheduler is continuously updating the rig schedule to reflect these changes made to the different estimates and other source inputs that we showed in that previous slide. This creates constant thrash in the organization as schedules shift and teams scramble to adapt. So what changes with the lakehouse? Well, let's show the transformation that's possible with a lakehouse enabled approach leading to these optimal outcomes. Instead of fragmented data, all data sources are being brought into a single source of truth, the enterprise lakehouse. This eliminates those days and weeks spent reconciling numbers between systems. And for drilling engineers, this means ease of use and confidence in data. We don't stop there. As we see today, we're going to have machine learning coupled with custom application development, which results in more accurate estimations developed in a more efficient manner. The impact on the rig schedule is dramatic. With more accurate estimations, there's less need to update schedules. This results in less thrash among operational teams and success in dependent workflows. This isn't just theoretical improvement, it's a fundamental transformation for how well planning works, enabled by the modern data architecture and AI capabilities. So now that we better understand the problem, I'd like to dig into a solution that we developed leveraging Databricks intelligence platform. Sergey is going to be walking through a live demo of this momentarily, but before we get to that, I'd like to introduce a few concepts, especially some of the newer technologies that we've recently announced at Summit and in the previous months. I want to start with Lakeflow, which is our unified data engineering platform, previously called DLT. In the in the traditional model, data engineering is complex, fragmented, and time-consuming. Lakeflow changes this by providing a single integrated platform for all of your data engineering needs. Lakeflow handles the heavy lifting of data integration, allowing your teams to focus on analysis and decision making rather than data plumbing. This is the foundation for what makes everything downstream possible. Lightflow provides three key pillars that transform data engineering. The first is Lightflow Connect, which seamlessly brings in data from all of your source systems. Whether it's streaming telemetry data, batch files, or external APIs, we have connectors built into major database systems and applications such as SQL Server, Oracle, Salesforce, etc., with more connections coming in the coming months. The next big pillar is declarative pipelines. We use declarative pipelines to clean, enrich, and prepare data for analysis and work it through the medallion architecture that we're leveraging here at Databricks, which is the bronze, silver, and gold. We'll get more of that here momentarily. This the declarative pipelines component is really what we'll be focused on today. The final component of Lightflow is Jobs. Jobs is our orchestration platform that manages workflows and dependencies, logic as well. And so it's our way of orchestrating these complex data engineering pipelines. What makes it powerful is that these aren't separate tools that you need to integrate with each other. You're not using a separate orchestrator, a separate pipeline tool, a separate connection tool. They're all a unified system that handles your entire data pipeline from source to insight. So going back to Lightflow Declarative Pipelines, or LDP, as you'll hear it referenced, is really built on this declarative framework, meaning you declare what transformations you need, and LDP determines and automates how to execute. We have a new multi-file editor that was recently released, and we're taking the developer experience to the next level. It's now easier than ever to structure transformation logic, configure pipelines, iterate quickly throughout the development lifecycle. And the editor feature really highlights that. Lightflow declarative pipelines makes it really easy if you can write SQL statements, if you can use some basic syntax to sort of declare upstream and downstream tables, you can really start to build out these complex DAGs that make your data engineering workflows seamless. So once your data is properly stored into the lakehouse in that bronze, silver, and gold architecture, we want to really talk about what can we do to start giving insights to the drilling engineer. And so we'll spend a little time today talking about AutoML. Databricks AutoMLs, it's not a new solution, but it's one that our customers are finding tons of value in still. It's what we call a glass box solution. It empowers data teams without taking away control. This is really crucial in energy applications where understanding model behavior is as important as model accuracy. Here's what really makes it powerful. You get a UI and an API to start experiments very quickly. With auto-created ML flow experiments that track models and metrics, the system performs AutoML training using multiple algorithms, automatically generating reproducible trial notebooks with source code for every model. And that's really the key differentiator compared to other black box sort of automated ML approaches. AutoML is not a black box, it's a glass box. You get generated notebooks with feature engineering, data exploration, and model training code. This means that you can understand and debug data quality pre-processing decisions, and you can easily update business logic in your model training notebooks itself. This allows you to easily create, high-value models that you can easily deploy via model registry and iterate further. Those first two technologies have been around, but these next two are where we're starting to discuss some of our newest features to the Lakehouse. I want to start talking about Lakebase today, our solution for applications that need transactional capabilities alongside analytical power. Traditional architectures force you to choose between analytical performance and transactional consistencies, but Lakebase really eliminates this trade-off. Lakebase provides Lakehouse integration with enterprise readiness. It's a fully managed Postgres system with separation of storage and compute, providing modern development experience built for AI. This is really a spinoff of we recently acquired Neon, which was a Postgres provider that really mastered the separation of storage and compute. And so Lakebase is our integration of that technology within our lakehouse. So what this means is that you can now build responsive, interactive applications that operate on the same data as your analytical workflows. No more data silos, no more complex ETL pipelines to move data back and forth between your OLTP and OLAP instance, which result in much more consistent and robust applications. So, how can you potentially use Lakebase and how we're using it in this demo today? The first is this section on the left-hand side, which is what we're calling reverse ETL. So the idea behind this use case for Lakebase is that you have data that you've massaged, put models on top of. It's highly aggregated, very sort of fit for purpose that's residing in your data lakehouse. And you want to be able to serve that up to an application through OLTP. What reverse ETL does is it allows you to automatically sync that data from your data lakehouse into your OLTP Postgres instance, which is on Lakebase. This makes it really easy to serve up that highly valued data directly within your application. The next use case is on the right-hand side, which is around storing application state. And so the idea here is that you can now start to build out your entire application on top of Lakebase. You can store different user states, inputs, etc. You'll see that here today as well. And then finally, the last sort of feature of Lakebase, which is in private preview today, is that same sync back into your lakehouse. And so maybe you're storing application states, or in our case, we're actually going to be writing our AFE estimates or our days on location estimates to our OLTP instance. And we can easily sync that data back to the warehouse for further analytical use, such as Genie rooms, downstream modeling, etc. Once again, that's in private preview, but coming soon. The final big chunk of what we'll be talking about is around the Agentbricks multi-agent supervisor. Um, just as an introductory to Agentbricks, Agentbricks enables several powerful use cases for energy companies by building out robust agentic modules, or bricks, is what we call them. Right now, we have four available. Information extraction, which turns unstructured data into structured insights through summarization, classification, key information extraction. You can think about processing drilling reports, PDFs, things of that nature, and getting them into a Delta table. Custom LLM, which specializes in development of LLM endpoints to your domain-specific guidelines using your unstructured data. This really means building AI that understands energy terminology, regulatory requirements, and operational context. Our knowledge assistant brick turns your documentation into an AI expert within a few clicks. And then finally, the one that we'll really be highlighting today is our multi-agent supervisor. And so this brick really creates an endpoint for you to leverage that allows you to design AI systems that bring together Genie, other agents that are seen on the screen, and various AI tools that can enable complex workflows that can reason across multiple data sources and different agentic bricks that you've seen here today. So now that we've sort of seen some of these capabilities or discussed them at a high level, I want to take a minute to sort of walk through the architecture of what Sergey is going to show here momentarily. So here on the screen is the architecture that you'll become readily familiar with here once Sergey opens up and starts showing the demo. But I want to walk through some of the key points to really think about today. First is that bullet point one, which is around sort of ingesting and transforming data through Lakeflow. In this use case, we've taken several source systems, ingested data into our lakehouse architecture of bronze, silver, and gold tables. For those that don't know, bronze is sort of our raw file staging area, and then silver and gold are more refined data sets up until gold, which is sort of our fit for purpose use case. And so we're using Lakeflow to ingest this data, transform it, and put it throughout that medallion architecture. We haven't touched on this much today, but just for clarity, we're still sort of leveraging some of the key fundamental Databricks capabilities, which are obviously storing data in open data formats such as Delta Lake and Iceberg. Under the hood of LDP, we're still using Apache Spark and Photon as the engine that does these transformations. And then ultimately, all this data is ending up being tagged by Unity Catalog, where all the governance and security and lineage tracking is taking place. But regardless, we've used LDP in this case to get this data into our medallion architecture. And then from there, we can start to do some really cool things and build on top of this. Bullet point two is where we're actually pulling in data around cost and phase data, time estimation data to build out some different models that our drilling engineers will use within the application. Um, we built pretty simple models today, but these could be as complex as you want. We leveraged AutoML, which we talked about was that glass box solution that created some model endpoints, which will then be consumed with our Databricks app in the drilling estimates modeling component. The next sort of box is around the lake-based OLTP Postgres instance. That's going to be that lake-based concept we talked about. That first bullet point number three is our reverse ETL framework, where we have gold data. We have some highly aggregated data sets that has been ran through our medallion architecture, and we want to serve that up to our application. And so we use our automatic lake-based sync tables to do reverse ETL on that data. It syncs that data directly from the lakehouse into Lakebase, which can then be consumed within our offset wells analysis. Once the bullet number four is around sort of that vanilla ETL or being able to build out application state on top of Lakebase. What we're doing with that use case is you'll see Sergey is going to be able to actually write these estimates that he's coming up with based on our models directly back to our OLTP instance. And then we can automatically sync that back into our lakehouse or further downstream analytics. Once again, that bullet point number four is the component that's in private preview, but still will be really good to show and excited for that use case. The final sort of new technology to pay attention to is that multi-agent supervisor. As we mentioned, and a lot of our customers are seeing a really big traction with our Genie AIBI Genie technology, which is our natural language sort of text to SQL engine that allows users to interact and ask questions in natural language and get results back. In our case, we developed out a few Genie rooms. We have an NPT Genie room, we have a drilling cost Genie room, and so our multi-agent supervisor actually sits on top of these different Genies, provides an endpoint for our application to interact with. And so when we ask it questions, it's going through and it's figuring out where exactly it needs to route those questions, the logic needed to, is this a cost or an NPT question, and allows us to sort of make our needs much more robust and sort of chain them together. So, Sergey's I'm turning this over to Sergey now. He's going to walk through all of this technology, but yeah, definitely keep these big five pillars in mind as you see the solution. Sergey, with that, I'll turn it over to you.
Right. Okay, let me know if you see my screen and hear me well.
Yep, we see you.
Awesome. Thank you, Brad, for setting the use case and overview of related Databricks services. My role for the second part of the session is to showcase the Databricks services capabilities and how they incorporate that in the web application. So let's move on and use the following scenario. I'm a drilling engineer who recently joined the team. I don't have much information on how the data is organized in the lakehouse, what the schemas and table structure is, and so forth. So my manager gave me access to the application and which I need to discover and start working on my first drill plan. So let's take a look at what the components the application consists of. So I see the sidebar or form with the inputs, tabs. On the main page of the application, I see the map view, right? And I also see the AI assistant and the bottom right corner here. So, and first, as I mentioned, I don't have many details on the structure of existing data. So I would like to start my journey by challenging the AI assistant to get some information on this, right? And I have a couple of questions. For example, my first question is about the unique wells on the unique production formation. So I'm gonna ask the question, which I already prepared. So while the assistant thinking, I want to share my expectation for the AI assistant. Uh, okay, we are. This is the real-time demo. So, and we work on the demo environment. Let me show you maybe the backup uh, of the question. So, I asked the question about wells for each unique production formation, and in general, my expectation on the AI system that the AI knows well the data structure, its sources, and how to manage the user request and respond correctly. Right? Let's get back to the previous step and try once again on the live demo and ask the another question, which is the what well in Wolfcam had the highest NPT cost. So again, as you can see, I used English instead of SQL or Python code. So this is the user interface that the application provides us as the end users. So let's wait the answer from AI. Again, the real okay, it's a demo. So we have the well name and also we have the NPT estimated cost. So it means that I used English, not SQL, not Python. So it seems to be working, and let's start work on my first drill planning. So first of all, I'm gonna start with the offset analysis. I'm gonna use the map view on the main page. I also have the target formation select box here, and I can navigate through all the options, see the location of the wells on the map, right? Get the data, zoom in or zoom out, kind of navigate through the map. I also want to see some historical data, or at least data from the 10 last wells created, right? Is the for target formation like Bone Spring, I have the ratio between depths and cumulative days. I see kind of dashboarding, right? But I used to use the external tools like Power BI or visualization tools, but now everything incorporated in one place in the application, which is awesome. I see the job cost. Again, maybe some additional filtering capabilities will be added later for the application, but it's useful for me, right? So also I'm gonna kind of have some estimation. As far as I know, there are machine learning models under the hood, so I can make the adjustment of the inputs and see the predictions updated for each cost phase, right? And also I have total well cost, and also I'm gonna have estimations from the machine learning model for time estimation. Let me change geologic risk index, for example, right? The prediction updated for each subphase, and I also have the total days on location, right? So I done with the offset analysis, reviewed the dashboards, got my prediction from machine learning models, right? It's time to save my estimations for maybe get back to the estimations tomorrow or in 1 week, or even share the estimations as my colleagues did, right? I will have to put the API number, which is required. Let me use like this one. So I'm gonna work let's use this target formation and it's done. I will uncheck this select box, which means that if I check this select box, the SME agent, like intelligent SME agent, will review my inputs and estimations regarding the outliers anomalies. So, and will put the stamp, review stamp, right? It's just the requires my attention. This is some anomalies here. Here, so everything looks good, right? I will save without it. So just to see my record here, and also I will do it once again because we not require the API number is unique or for the application for the sake of demo, right? And I will save it, but we will not wait because it can take some time. So if we will have time, we will get back to the screen and I will show you this stamp. So it seems to be working, right? And now let's go to the Databricks user interface where I can show you um, how the all the Databricks services can be easily created and which I used for the application and show you a moment ago. So uh, what we did, we asked the AI assistant some questions, right? We examined dashboards. We used machine learning predictions. We got the AFEs, total days on locations. So first of all, the application, right? So this is a web application, which I demonstrated a moment ago. So, and I want to finish this topic, and then we will focus on data, ML, and AI. So, let me show how to create the application. We go to Compute, Applications, Create App. So, Databricks apps are the fastest and most secure way to build data and AI application on the Databricks data intelligence platform. Like personas like developers, data scientists, or data engineers can create application using a popular Python framework such as Dash, Flask, Radio. For our demo, we use Streamlit. And also, they can choose from pre-built Python templates for their application like chatbot, data app, or LTP database. So Databricks apps provide the serverless deployment and built-in governance, which means that the engineers doesn't require to build additional infrastructure. The application run automatically, provision in serverless compute, allowing deployment with ease, and of course, production readiness. So I will not create one more application for the demo. Let's me show the application that we used for the demo and I demonstrated a moment ago. So let's get back. I will use Energy Well Planner app. Uh, this is the deployed application which has the running endpoint, right? I use this endpoint as URL for my application, and also it requires the source. Like if we go to the source, right, we see this is the workspace folder with Python code. That's it. So as soon as code uh, uploaded to the workspace folder, we click deploy, and Databricks apps will manage all of this stuff. I mean, infrastructure and um, readiness of the application. So uh, we got the application. Now, as Brett mentioned, data may come from many sources and even in different formats, such as unstructured, semi-structured, or structured formats, or even in form of batches or stream, right? And our goal is to ingest the data, improve its structure and quality, and make it actionable. So we used Lakeflow declarative pipeline tool, which allowed us to instantly build a data pipeline with bronze, silver, and gold tables from just a few lines of code. So let me show how the pipeline looks like. I go back here and here. So this is the visualization of pipeline, and maybe let's go deeper. Uh, we use the code to manage the pipeline, right, to specify materialized view, and also you can use the visual tool to manage the steps of the pipeline, right, to create streaming table or materialized view. So the wonderful like features that the pipeline provides is the constraints and quality expectations, and also we used, as you can see, like live. That means that we use the streaming view for is like streaming table, which means that new data come, the downstream tables as well will be updated. So, and the data in the lakehouse right? We ingested it, it's cleaned, aggregated, but isn't built for low latency app interactions, right? Or transactional workload. And let's see how easy we can sync gold layer data from our materialized views into fully managed Postgres database. So to create the lake base, we go to compute, OLTP database, the feature in the preview. If you don't see the tab in the compute page, please go to the preview features from if you are workspace manager or admin, you will be able to uh, uh, activate the feature, right? So OLTP database, create data instance, couple of settings like name, capacity unit, then high availability of the instance, right? But again, I will not create the database instance for the demo. We also have created instance. Let me go to the instance and show you couple of details that we have, right? The connection details for your application, permissions management, right? And also you can make all the tables, I mean Postgres tables, as the Unity catalog tables, which will be available for your Unity as a regular Unity catalog tables or views uh, for your Python, PySpark code or applications. So um, Brett also mentioned that reverse ETL, right? We have the database created. Um, we can leverage the reverse ETL approach to sync data from Lakehouse table to the Postgres tables. And also, it was mentioned that Lakebase combines the high-performance Postgres engine. It has deep lakehouse integration and built-in data synchronization. So the fresh insights flow into application without any extra infrastructure, right? So let me show how to create the reverse ETL pipeline in Databricks. So I go to the my Unity catalog. For example, I want to use my goal table, which is the data, for example, we used for our application from Lakebase. I mean, for data in the view map, for dashboard, and right. So I have the summary goal for job, right? I click the table and then click create sync table. So here are a couple of settings like Postgres table name, database instance, primary key to do synchronization, right? And sync mode, which is snapshot, triggered, or continuous, and create. Again, I want to create the lake base for the demo. Let's, I mean, sync table, right? I already have the created gold table. Let me show you how it looks like. So we have source table, which is drill job summary gold. This is the Unity catalog table. And also we have pipeline ID, which is responsible to synchronize data from Lakehouse table to the Lakebase table, right? I mean Postgres. And I have sync now button to synchronize data manually. So, but again, it depends on the sync mode, which I showed a moment ago. All right, so again, new data come here. We have data in Postgres, data ready to consume from the application. So for visualization and so forth. And also we used Lakebase to save the estimations, as Brad mentioned, right? So let's get back and we covered like data topics, right? And we have data in Lakehouse and also in Lakebase. Now let's talk about the machine learning models. And as Brad previously mentioned, Databricks AutoML is the easiest way to train and serve machine learning models. This is a glass box solution which empowers data teams without sacrificing the control. So let me demonstrate the machine learning model creation in AutoML. So I will get back to the um, Databricks UI, then goes to experiments. So as you can see, AutoML supports the forecasting problems, classification, and regression. So if I go to the regression, for example, right, this is a couple of settings which require AutoML requires from you, just the experiment name, sorry, let's go cluster, predefined cluster, right? Input as a training data set from Unity catalog tables, prediction target based on the data set here, and couple of advanced configuration like evaluation metrics and so forth. So again, we already have created machine learning models. So at least we have predictions models for job time and job cost. So let me show you how the models look like, right? I can find my models in the Unity catalog. So I can go to the uh, catalog and see a job phase time model and drilling cost model. Later on, I will say how we can get the models registered in Unity catalog. But I can open, for example, job phase time model here, right? This one this model has two versions, which one of them already promoted to production. And let's go deeper and see what inside of the model, right? So it allows the inputs, lineage, traces, but we are interested in how in general the model was trained, right? If I go to the source run, I can find the metrics, evaluation metrics, hyperparameters which used for the last run within experiment. But if I get one step back, right, I can see in general the whole picture how the model was trained, right? I see the target column, I see the evaluation metric, and uh, within the one experiment, the AutoML creates the explorational notebook, which Brett mentioned, right? If I go to the exploration notebook, I will see the how AutoML um, kind of sees your data. It tries to get the statistics on data on the data set, right? It helps to better understand the problem and work on the algorithm for model training, right? And also model selection, right? As you can see here, let me do this, right? Within one experiment, we have multiple runs for different algorithm and libraries used for model training, right? And we can see that the last run, that XGBoost regressor, shows the better performance of the model based on the evaluation score, right? And if we want to see how the model trained within this run, right? Or we can bring some expertise, or we are not satisfied with the run, and we want to improve it, right? We can go to the notebook here, or even here, right? You see like notebook for best model. We open and see the whole process, how the model trained, how it managed the uh, data set, some transformation of data, right? And if I scroll down, as soon as we're satisfied with the model and we want to use the model for inference, right? First of all, we need to register the model. So, and to register model, we can do this programmatically or in UI, click the button. But the idea is if you want to have your machine learning model or output of the AutoML in Unity catalog, you need to register the model in your model registry. We used Databricks UC registry to register the model, not, I mean, this code, right? And for inference, we have two options. We can use the model as a PyFunc, right, in our PySpark code or SQL, or we can use the endpoint like for REST API. In our case, in our application, we use the REST API to provide the inputs. send the request and got the predicted cost or time to get the predictions from the models. So we have two separate endpoints for each model. Let me show you how to get the um, how to read how to serve the model, right? I go to the my Unity catalog, right? I have model. I use the job phase because my model is registered and click serve model. So again, I can do this programmatically and I can do this from UI. So even we can have multiple versions served, two separate endpoints, and we can manage, let me show you quickly, split the traffic. So if you want to check the, make some A/B testing or performance testing, right? So this is how it works, how the model serving process looks like, right? And also few words about the notebook, which I showed before, is that we can use the notebook for um, to deploy code, not deploy model, which means that if you have production environment, we can use the notebook to train model right on the production environment, use the production data rather than thinking how we can move production data or get access to production data for training from dev environment. So this is for AutoML. So we consider the data pipeline management and used AutoML to train the models for predictions, right? Which we used with data we used from the pipeline. So last thing I wanted to demonstrate today is how easy AI assistant development is. So again, I go to the agent here, and as Brad showed, we support four like use cases. And for this demo, I'm interested in the multi-agent supervisor. I can click the build. So couple of settings again, just name, description, and I'm really encourage you the better description you provide, the better performance of your agent. And also we can create up to 10 different agents and tools which supervisor will manage, right? We can use as of now is a Genie space or agent endpoint, and you see MCP is coming soon. So and couple of optional settings here like format or tone is like system instructions for the multi-agent supervisor. Again, we already have created supervisor. This name is a drilling job supervisor. And as far as you can see, we provided the description for supervisor, which is the drilling expert, like in oil and gas. It manages three Genie agents, which is the cost Genie agent, MPT Genie agent, and time Genie agent. And all of them has the instructions, right? Their specific roles within this agentic system, right? And if I go deeper, for example, for this Genie space, I can show you quickly that we have, first of all, data, right? We use Unity catalog tables to provide the data which this particular Genie space manages. Please, as the best practice, do not kind of add all your tables, all the tables you have, and a Unity catalog to the one Genie space. This is kind of one of the best practices for Genie spaces, right? And we have instructions. It's like you are drilling engineer and couple of uh, some some kind of guidance for the agent how to manage the user's request and where to find data if there are some intricacies within data structure. So uh, again, three Genie spaces, three agents with separate instructions with separate roles. And I also can even I have questions and I can play with the agent, right? The Cost Genie agent in the playground in Databricks UI, right? Or even I can go back and ask the same question. Let me show you, which I used, for example, like this, put it here and ask the multi-agent supervisor to provide me the answer on the on my question, right? So I can see here the how it thinks, right? I see the trace. Let me ask the another question like this. So, and even if I'm not satisfied with the quality of the response, you see, I can improve the quality. So, last thing that I want to show you how we can see the trace here, but you can ask how we can trace the request and see it in general, the logs of the request to the agent if our users, I mean, application user will send the request to multi-agent supervisor. This is the great question. And we have the ML flow experiment here. I will click on the link, right? And here the all requests logged in Databricks, right? We have requests, we have response, we have execution time. And if I click any of them, right, I can see the initial request from the user. I have the details and see the breakdown and flow of the query, right? For example, here the agent tries to understand the context, then try to delegate the query to the agent, and even you can see what exactly SQL the Genie agent invoked, right, to get the data and provide back to the as the answer to the end user, right? And again, we deploy the multi-agent as the endpoint, and we use the endpoint as the for REST API from the application from the UI. So again, we covered lake base, saved in the lake base. We use the reverse ETL to get data from lake house to the lake base for the application, right? For operational data. We used machine learning trained using AutoML, and we use the bootstrap, like ask AI to review our inputs and put our stamp here, which is this one. So I'm done. Thank you for your attention. Brett, over to you.